Good afternoon, all of you. If there are any discussion, please type in your chat box. If you have any queries, please post it on the chat box. Participants, those who have joined, if you have any queries, please post it in the chat box. If we don't receive any query within 15 minutes, then we will close the session. We understand that there is no clarification needed. Okay. There is a question like end of construction is the most critical phase related to stability. Why? This is not a mandatory condition always. It is with respect to that particular condition, you need to see the effective stress path. In certain cases, immediately after the construction, the effective stress path will be close to the critical state line or the failure line, and after the end of construction you will see that the effective stress path moves away from the critical state line. In that case, the end of construction is not really the in fact that is the most critical phase. Why? Because with time factor of safety is improving, that is, it is moving away from the critical state line, and this generally happens when you have positive water pressure. And when positive water pressure it's a positive water pressure at the end of construction. Now when the positive water pressure dissipates, it moves away, but in certain cases you have at the end of the construction there will be a particular state. Now with time what happens is effective stress path will move towards the critical state line. Okay, in that case also it is considered to be what do you say, the end of construction is considered to be, it's not considered to be that critical, because it is otherwise going towards the failure line. So why it is considered to be a critical state at the end of construction phase, then it is those cases where at the end of the construction there is a possibility of failure, but with time it moves away from the critical state line. So only in those cases it is considered to be a the what is say, it is the end of construction is the most critical phase. Any other clarification? Okay, the next question is what is residual strength, and is there any significance of it in geotechnical problems? In fact, residual strength has significance only in geotechnical engineering. If you see the lectures, you will understand that the residual strength happens at a very high strain, and this is a typical problem wherein you have landslides occurring, for example, or slope instability, and a mass of the soil is moving downwards. So it has already started failing, but it has not completely failed. A mass of soil is still undergoing a very large deformation or a very large strain, and that particular point, whatever is the very less amount of strength that is available, that is known as residual strength, and that has a lot of importance in geotechnical engineering, especially related to problems like slope instability or landslides. Okay, so the next question is, can you please explain about the difference between the pore water pressure immediately after construction and the pore water pressure for excavation problem. Immediately after construction is a more general case. This pertains to whether it's a foundation engineering or whether it's an excavation or whether it is a retaining wall construction. Whatever be, the end of construction means immediately after the completion of the construction, and you can call this as a short-term response. Short-term response of that particular construction. Now, when you have short-term construction, depending upon whether you are loading or whether you are releasing, it depends, the pore water pressure accordingly changes. Now, if you are further loading the system, the pore water pressure will be positive. Even at the end of construction phase, it will be positive. Now, in certain cases, when there is release of load, the pore water pressure tends to be negative. Now, what happens is this pore water pressure dissipates over a period of time. So, when it is a positive pore water pressure, it dissipates and it sheds off that excess pore water pressure, and hence it moves in a particular direction from the critical state line. Now, your question is what is the difference in pore water pressure immediately after construction and pore water pressure for excavation. So, in pore water pressure for excavation problem, I understand that it is negative pore water pressure at the end of the construction. Now, this negative pore water pressure adds to the safety. Now, what happens is this negative pore water pressure gets dissipated, and when it gets dissipated, it moves towards the critical state line, and that creates there's a tendency for failure. Any more questions? Okay, the next question is why can't we use curved failure envelope obtained in UU test since it finally reaches SU after some time? You can use the curved failure envelope which you get in UU test, provided you don't fit an inclined failure envelope to that curved portion. If you understand that it reaches the saturation after some time of loading and it becomes fairly horizontal, that is the failure envelope which you need to consider, and that will be SU. But what happens is in certain cases people tend to fit a straight line to the curved portion, and in the process they would report phi value, which is not correct. If you know that it's a UU test, then phi is equal to 0. So ignore the curved portion, and the other flat portion is SU. Yeah, if you have any questions, please go ahead with your queries. Is excavation problem considered as release of axial stress, keeping radial stress constant? In fact, it is the other way around. The axial stress is constant and you are releasing the radial stress in the excavation problem. The lateral stresses are released, isn't it? I mean, it is very specific to the formation of a slope. Like you're taking away the soil and a slope is formed. So, in that case, the radial stresses are released. Yeah, if there are no more questions, then we can wind up the session. We'll wait for 5 more minutes. If you have any queries, please type on the chat box. Else, we can wind up in 5 minutes. Okay, participants, I understand that there are no more questions, but I would suggest that you please go through the lectures, and if you have concerns, please enter it in the Excel sheet so that that will help me to go through the problems, and I can also refer back to the slides while explaining, and please utilize more of these live sessions if you have any concerns. So I think let's wind up for today's lecture, as we don't find any more queries coming from you. So that's all for now. Thank you. Have a nice day.